Okay, let's do a little fraction review, starting with the basics. So add, subtract, multiply, divide. So remember, when you add or subtract, you have to get a common denominator because you've got to be putting the same size pieces together. So let's just start with basic fractions. So let's say that we have like 2/3 plus, let's say 4/5. Okay, so to put these together, we need a common denominator. That's going to be 15. So the first one, we're going to have to multiply by 5. And to do that, we need to multiply by 5 over 5, because then we're multiplying by 1 and we haven't changed anything. So we multiply the first one by 5 over 5, multiply the second one by 3 over 3. Okay, so the first fraction becomes 10 over 15, and the second fraction becomes 12 over 15. So now they've got a common denominator, same size pieces, we can add them together, and we get 22 over 15. Okay, and then subtraction would be the same exact thing, just opposite signs. So let's say we have like 1/4 and 5/6. Okay, now for this one, you could do a common denominator of 24, but there's a smaller one, which would be 12. So if you don't see the least common denominator, it's okay, because you can always reduce it in the end. It just makes it a little bit easier if you find the least common denominator. But as long as you have a common denominator, you're okay. All right, so we can get to a common denominator of 12. So that means we need to multiply the first one by 3 over 3. And we need to multiply the second one by 2 over 2. So the first one becomes 3 over 12. That's the same as 1/4. And the second one becomes 10 over 12. Okay, and now they're both over 12. They've got a common denominator, so we can do 13 over 12. Okay, now multiplying fractions, remember that you multiply straight across. So if you have like 1/2 times 4/5, like that, you would multiply straight across the numerator and straight across the denominator. So you would do 1 times 4 over 2 times 5. You would get 4 over 10. And then that you can reduce each of those by 2, and you can get 2/5. Okay, now this one you can always multiply and then reduce, or you can reduce and then multiply. Either way is fine. So if in the original problem, I'll rewrite it. Okay, so in the original problem, you may have said, well, it's 4 over 2, even though they're diagonal, it's still 1 and 4 over 2 and 5. So the 4 is over the 2. We can reduce those both by 2. We get a 2 on top and a 1 on the bottom. Now when we multiply, we've got 1 times 2 is 2. 1 times 5 is 5. Okay, but remember, you can only reduce when it's all multiplication division. You cannot reduce over addition subtraction. Okay, you've got to, if it's addition subtraction, you've got to combine it, and then you can reduce. Okay, let's do one that's division. Let's say that we have 1/3 over 2/5. So remember, dividing is the same as multiplying by the reciprocal. So you've got 1/3, then this is going to change to times, and then the reciprocal, 5 over 2. Okay, and now we can multiply 1 times 5 and 3 times 2. So 5 over 6 is our final answer there. Okay, so now let's do these same things, but with pi. The pi part pretty much just sits there. So if you're doing like, let's say you're doing pi over 4 plus pi over 6. Okay, it's the same idea as what we just did. It's a common denominator of 12. So the first one I multiply by 3 over 3. The second one I multiply by 2 over 2. And I'm going to get 3 pi over 12. And I'm going to get 2 pi over 12. Okay, so see, the common denominator step, the pi didn't change anything, it's just sitting there. And now when we combine it together, instead of just 3 plus 2, it's 3 pi plus 2 pi, which is the same thing. So we get 5 pi over 12. Okay, so throwing the pi in there doesn't really change these, the basic rules. Okay, and then if you have this came up in the classwork, if you have something like 4 times pi over 5, okay, that's multiplication. Remember, you multiply numerator and denominator, so this is really the same as 4 over 1 times pi over 5. So we're going to have 4 times pi over 1 times 5, and that's going to be 4 pi over 5. So just be careful with that you multiply the numerator, because sometimes when it's written like, let's say it's written like this, okay, that 3 out front doesn't really look like a numerator, but it really is. You've got to remember that that's over 1, so that's going to give us 6 pi over 3, or we could have reduced the 3's there. 6 pi over 3, and then we can reduce that by 3 and get 2 pi over 1, or just 2 pi. Okay, or we could come back to the beginning and reduce the 3's there. Okay, so that's the basic idea with the basic operations. Now, one that we were using repeatedly to get a common denominator was 2 pi. Okay, so take out the pi for a second. 2 is the same as 2 over 1. We don't really need that for a common denominator. It's the same as 4 over 2, 6 over 3, 8 over 4, 10 over 5, 12 over 6, 14 over 7, and so on. So see, the top is always the denominator times 2, because that's when it reduces, it's going to be 2. So anytime you're looking for a multiple of 2 pi, it's always just going to be double on top. So you would have 4 pi over 2, 6 pi over 3, 8 pi over 4. Okay, so see, that pi doesn't change anything. We're just looking at the numbers out front. Okay, and doing that conversion really quick will also help you decide if a number is between 0 and 2 pi. Because if you've got a fraction, you have to decide pretty quickly, did I get it between 0 and 2 pi, or do I have to keep going? Okay, another thing that we need to get pretty good at is counting by fractions. So, like, let's say that you want to count by half. That's probably the most familiar to you. So if we want to count by halves, it would be 1/2, and then 2 over 2 would be 1, because we know 1/2 and 1/2 is 1. Okay, and then the next increment would be 3/2. And then, so it's 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2, and so on. You keep going like that. And then every other one is going to reduce. So this one, here, let me write it in as 2 over 2, because that's what it would have been if we had been consistent. So see, I have 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2. But some of these reduce. So 2 over 2 is the same as 1. 4 over 2 is the same as 2. 6 over 2 is the same as 3. So when you're going through and counting these increments, as you're counting through them, 1, 2, 3, 4, 5, see if any of them will reduce. So if instead of counting by half, we want to count by pi over 2, again, it's the same thing. The pi is just in there, sitting there, not changing anything. So if we want to count by pi over 2 increments, we'd have pi over 2. Okay, then 2 pi over 2 is pi. 3 pi over 2. 4 pi over 2 is 2 pi. 5 pi over 2. 6 pi over 2 is 3 pi. 7 pi over 2. 8 pi over 2 is 4 pi, and so on. We can keep counting like that. Just reduce the ones that can be reduced. So let's say that we want to count by 1/3. Okay, so I'd say 1/3, 2/3, 3/3, 4/3. Whoops, I did a 4 there. 4/3, 5/3, 6/3, and so on. We would just keep counting by thirds. All right, but some of these reduce. 3 over 3 reduces to 1. 6 over 3 reduces to 2. And then we keep going. 9 over 3 reduces to 3. So if you can kind of do that part in your head and reduce them, then you don't have to write it down twice. So if we're counting by pi over 3, okay, we've got pi over 3, 2 pi over 3, 3 pi over 3, that's just pi, 4 pi over 3, 5 pi over 3, 6 pi over 3 is 2 pi, 7 pi over 3, 8 pi over 3, 9 pi over 3 is 3 pi. Okay, so now without doing the fractions, let's try to count by pi over 4. Let's see if we can do that. Okay, so we're going to have 1 pi over 4, 2 pi over 4, that reduces to pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, I'm going to write this one down. 6 pi over 4, that's going to reduce to 3 pi over 2. Okay, so we've got 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. The next one would be 7 pi over 4, and then 8 pi over 4. And we say, hey, now that reduces to 2 pi. Okay, so for most of these, you're just going to count around to 2 pi, because if you're doing increments, you're just trying to get around the circle one time. So pretty much once you get to 2 pi, you're okay. But that's how we're going to count by fractions, whether it's a plain fraction or whether it's got a pi in there as well. Okay, so let's do one more where we're counting by fractions, but we're going around the unit circle with them as angles. So we just did pi over 4, so let's try to put that onto the unit circle. So remember, we start at 0, and we remember that pi is on the other side, and halfway is going to be pi over 2. Oops, that's pi over 2. I was a little sloppy there. Okay, so halfway between 0 and pi over 2 would have to be pi over 4. Okay, so there's pi over 4. So pi over 4 is going to be halfway between each of the axes, okay, which is the same as 45 degrees. Okay, so 0, pi over 4, 2 pi over 4 is the same as pi over 2, 3 pi over 4 would be halfway again, 4 pi over 4 is pi. Okay, 5 pi over 4, 6 pi over 4, and that's the same as 3 pi over 2. Okay, so that's 6 pi over 4, 7 pi over 4, and then one more brings us to 8 pi over 4, which is 2 pi. Okay, so you should be able to count around in these fraction increments between 0 and 2 pi so that you can break the unit circle into any fraction. The most common ones are denominators of 2, 3, 4, and 6. Those are the ones that we're going to do the most. So you may want to just practice writing out those fractions. So denominator of 2, 3, 4, and 6 are the most common denominators, and practice writing those fractions out, and that'll help you go a whole lot faster when we're doing these problems.